Well, this is ErShoaibAhmad, and today I try to demonstrate how to use autoencoder in a deep learning. So, autoencoder is a type of artificial neural network, and it's like a magical technique and it's basically it's used in unsupervised machine learning where we don't have a level data and in autoencoder we give a same input to input as well as outputs. I know like it sound crazy, but autoencoder work in such a way like we have three layers. The first is encoding layer, and middle is the processing layer, and in the end we have a decoding layer. So we give input to encoding layer and processing is take place in a middle layer, and output layer try to reconstruct the same input from the input layer and give in the output. I know it's little bit confusing, but it's a magical technique and it have a huge number of applications such as anomaly detection to remove noise from the images. And here I'm gonna present you one of the use case of autoencoder where I gonna reconstruct the image from the noisy image. So let's have a look to a notebook. So here's the supporting libraries which I import, and I use TensorFlow 2.0 and it's all supporting libraries. And here I used a pre-inbuilt dataset that is called MNIST, and here I splitted my data into xtrain, ytrain, xtet and ytest, and the shape of data is 6000 images and the image size is like 28 by 28. So here it's a type of visualizations, single visualization of image, and here also multiple grid visualization of image data into a grid view. And so the data is very clear. So because the demonstration is for autoencoder, so I need to add some noise in a data so that we test our autoencoder neural network. So here I use some noise over there and added in a data a random. So here is one of the random image that is 1011 from 60,000, and I added noise of 0.4 over there, and now it's look like this. So it's little bit aggressive, and the main part is our neural network. So again, it's as I told in a starting of video, it have three layers, that encoding, encoder and decoding. So in encoding, it's we create a simple type of convolutional neural network and convolutional layer. So we add convolution layer and with a 25 filters of 3:3, and strides is one. Strides like when we convolute two matrices, so how much like we need to shift, it's like a shift to a next column. So the stride is one, so the shifting is also a one. Padding is something that's the shape of input is equals to the shape of output, and input shape is 28 by 28. Here I added max pooling layer, that is nothing but downsampling of image. Then again one more convolution layer, max pooling layer, and here it's encoding layer with 15 filter for processing. And after that the main is the decoding layer. So decoding is nothing but a reversed of or a transport of our convolution layer. So what we did, transpose, like in a convolution the first layer is convolution layer, then max pooling, then flatten and so on. But here no use of flatten because we don't have any artificial neural network. So what we did, like first upscale the image, like reverse, so upscaling, then after that convoluting transposed, so that the input try to reconstruct on the based of reconstruct the output on the based of present input over there. And here's the summary of my neural network. It have layers, max pooling layers, middle layer and transpose convolutional layer. Here I used losses, that is binary cross entropy, and the optimizer is Adam over there. And now I'm gonna fit my model with 10 beautiful epochs, and here we can see that the losses become down by down, and in that we have a loss of 0.0824. And now the magic is here, that is the images which contain noise, and here's the output. of autoencoder. It's like a magic. Thank you.